hang on. There you go.
So how many of you love math? How many of you even kind of like math or don't hate it? Okay, well today I'm going to tell you about a really cool kind of math. It's called modular arithmetic, and it has a lot to do with patterns. First I'm going to give you a crash course in modular arithmetic because you kind of have to know how it works in order to get the gist of it. And then I'm going to show you some real life applications. So modular arithmetic is just like normal math, it's numbers. The format is kind of special. There's a number, and then mod, which is short for modular, so you know that you're operating modular arithmetic. And there's another number, which is going to be your set number. So the set number here is a special number that you pick. If you want a set of 2, if you want a set of 4, if you want a set of 100, you can pick any number. So for our purposes, let's just say 5. So we're going to be in modular 5. What that means is that we're doing math, but we're only going to count to 5. We're going to start at 0 and go up to 5. So any number that ends in 0 or 5 is going to be the equivalent of 0 or 5 because they're equivalent in modular math. And then if you have 1, that would be 1. If you have 2, that would be 2. Let's say you have 13. 13 is going to be equal to 3. Now what you do is division. You take your number, 13, divided by 5. So 5 goes into 13 2 times. And your remainder you get here is 3. So your little remainder number is going to be your modular number. So if I had 27, it would be 2. If I have 30, it's going to be 0 because there's no remainder left over. Does that make sense? Okay. You can add and subtract numbers in modular too. So if I had 1 modular plus 37 modular 5, that would be 38 modular 5. But that doesn't work because this number is less than 5. So we do a revision again, and it ends up being 3 modular 5. Why is this important? Because of patterns. So especially when you get into scientific phenomena that only occur every several thousand or million years, you can use modular arithmetic to find out when the next occurrence will be. So how it works is you say, okay, say Mount Helena, St. Helens is going to erupt every 10,000 years. And you know it's been 8,000 years since the last eruption. Obviously I'm just making up numbers here. But so you know it's every 10,000 years. So then your modular is going to be 10,000. So this number here will be 10,000. And if you know it's been 8,000 years, then it's 8,000, and you know when it's going to happen again. 2,000 years, because it's 10,000 minus 8,000. But let's say you know an event is going to occur every 5 years. But you don't remember if it happened the last time it happened. But you remember it happened 24 years ago. So you can think of when the next time is going to happen based on that pattern of 5. So it would be like you have 24 years ago in modular 5. So you know that you've gone through 4 cycles because 24 divided by 5 is 4 with a remainder of 4. So you know then you're in 4 of your 5th person, or excuse me, time frame, your 4th year. So you know that the next year is going to be that perfect one where it's going to be that 5th year. Also, this is important in telling time. How many of you have ever been exposed to military time? Pretty much everybody. So if you think about it, military time is like real time. That's really the hours of the day. There's 1 through 24 hours. And technically, if you want to get really fancy, there's 0 hours, which is midnight. But military time is normal time. And then the time we tell, when we say, oh, it's 12:05 p.m., that's actually using modular arithmetic to find out what time it is. So get some clean whiteboard here.
You have 1 minute left.
Thank you. So we're telling time in modulars of 12 because 24 hours seems like a lot, and we don't like to say, oh, it's 0700 or it's 2300. In everyday speech we just don't use that. So we take that 24 hours and make it into 12. So if you have 1,300 hours in military time, that's 1. So you know that that's 1 p.m. It's not 1 a.m., it's not 1 p.m. Does that make sense? Okay. So now I hope you don't hate modular arithmetic because it can't help it. It helps us with patterns, and it helps you with telling time. Thank you.